growing use of electronic items has led to an explosion of electronic wastes, or e-wastes. In 2020, about 53.6 million tons of e-wastes were generated, and the amount is expected to reach 75 million tons by 2030. These e-wastes are the source of toxic substances, for example arsenic, as well as precious metals in their natural state, containing almost 20 to 30 times more gold and silver than metallic ores. To improve the recovery of these precious metals and remove toxic elements from e-wastes, researchers at Hanyang University have recently conducted research on an e-waste disposal processing facility comprising a pyrolysis unit, various separators, and a smelting furnace in collaboration with industry as well as national research institutes. While the pyrolysis unit minimizes the release of dioxins, a highly toxic organic pollutant, most of the precious metals that are combined with oxides and toxic elements are separated in the furnace via a high-temperature smelting process. Here, the various kinds of industrial wastes, such as the end-of-life EOL, PCBs, LEDs, catalysts, sludge, etc., are melted at high temperatures along with a well-designed flux and a liquid-collecting metal, such as copper. The fluxes lower the melting temperature and the viscosity of the molten slag, while the liquid-collecting metal provides a platform onto which the precious metals can dissolve and accumulate. To maximize the recovery of precious metals from PCBs, LEDs, catalysts, etc., the researchers investigated how the slag viscosity and composition, as well as the oxygen blowing method, affect the recovery rate and removal of toxic elements. They found that the recovery is highly dependent on the slag viscosity. Flux containing a high amount of silica increase the slag viscosity and confine the metallic copper droplets within the slag, lowering the recovery rates of precious metals. The researchers further enriched the precious metals by separating the impurities and the toxic elements from the molten copper. Moreover, they found that arsenic could be transferred more easily from the molten copper to the molten slag by increasing the concentration of calcium oxide and sodium oxide and decreasing the silica content in the slag. These oxides, such as calcium oxide and sodium oxide, trapped arsenic in slag, preventing the release of arsenic into the atmosphere. Currently, 85% of e-waste ends up in landfills or is incinerated. In light of this study presented basic data for economic and environment-friendly process development to recycle electrical and electronic wastes, as well as various industrial wastes, and effectively recover precious metals such as gold, silver, and palladium from them.